All right, so the key to what I'm having you do here is I want you to think about this intuitively, meaning I don't want you to think about the math. I just want you to look at this and think about what's actually happening here. If you haven't tried these questions yet before looking at this, pause this and go ahead and try these questions. See if you can figure it out. Okay, so it says, look at the graph below. The story goes like this. Mr. Devon gets mad at a student and decides to throw a paper ball at them. He barely misses. So here's Mr. Devon. He throws a paper ball, goes like this, comes down, but it just misses the student. So answer these questions. What does the x-axis represent? Well, let's not think about this mathy. Let's just look at the x-axis. Where is the x-axis? Well, the x-axis is this axis right here. What is that showing me? If I think about what happened in this situation, what is this showing me? Well, it's basically, this is like the floor, right? And what would I be telling off of this floor? Well, that's how far the paper ball went. So it's very simply how far the ball went. Oops. So it's how far the ball went. And so we would measure that in feet, right? This would be measured in feet, most likely. You could do it in centimeters, but that'd be weird because it'd be a ton of centimeters. Feet would be more realistic. Okay, what about the y-axis? So remember, our y-axis is right here. So again, you should be thinking about this intuitively. Don't think about it so mathematically. What is this showing? If you had like a big thing here, what is that really telling me about the path of this paper ball? Well, if this is the ground, this is the floor, we said, well, this is just how high it's going, right? That could be measuring how high. So this could just be the height. And it'd be in feet, right? Because again, you're going to measure that distance in feet, right? Vertical distance in feet. So this would be how high. Oops. Okay, so now we have what might the vertex represent? So let's look for the vertex first of all. Well, remember, so the ball's going up, going up, going up, going up, and it finally hits this point right here. And then it goes down and down. So this is the vertex. What does that tell me about the paper ball? What is significant about that? Well, first, it is how high it is, right? So it's telling me the height. And then we can also think about our symmetry, right? If I think about the symmetry going straight through this, well, remember the symmetry is will be halfway. So it's the height, and it's also halfway. So it's half of the distance. Okay, and the last one, the zeros. So where are our zeros? Well, the zeros are the x-intercepts. So the first zero would be right here, right? And then the second zero, where's the next x-intercept? Well, it's right here. Well, what is that significance of in the paper ball? Well, the paper ball goes up from here, goes down, hits the vertex, starts coming down, and lands here. Well, it's where the ball was thrown and where the ball lands. So where thrown and where it lands. So these are the different types of things I want you to start connecting to these words, like vertex, zeros, what the axis might represent. Don't think about it so mathematically. We're just thinking, what is really happening here? Well, ball went up in the air, came back down. What are the different ways I can measure that? Well, those things apply to the different things in the quadratics that we've been talking about.